Before we begin, a quick reminder. This video on the channel Blocks Bonds Funds is for educational and informational purposes only. It is not financial or investment advice. Welcome back. Today, we're diving into one of the most talked about but maybe least understood parts of Ethereum, gas fees. We're not just going to look at what you pay, but why you pay it. Because gas, well, it's the fundamental cost of running a computer for the entire world. So let's start with a really big question. I mean, a huge one. If you build a computer that literally anyone on the planet can use to run any program they want, how on earth do you stop one person from breaking it for everybody else, either on purpose or just by accident? That single question gets right to the heart of the computational challenge Ethereum had to solve. The dream was this decentralized world computer, right? But when you hand the keys to the entire world, you're inviting some pretty serious risks. This right here is a classic computer science nightmare. It's called the halting problem. On the left, you see a normal program. It runs, it does its thing, and then it stops. Perfect. But on the right, you have an infinite loop. On your laptop, that might just crash a single app. But on a shared network like Ethereum, a program that never stops could literally freeze the entire system, bringing everything to a dead stop. So the threats were very, very real. You've got bad actors who could try to spam the network with junk computations just to slow it down for everyone in what's called a denial of service attack. Then you've got honest programmers who might just make a mistake and write a bit of code with an infinite loop. And of course, you just have the network getting overloaded from tons of people trying to use it at once. Ethereum needed a shield against all of this. And the solution they came up with is, well, it's really elegant. Instead of building walls or trying to approve every program, they just decided to create a metering system, a way to measure computation itself. And this is where we finally meet the concept of gas. Now, this is absolutely crucial to understand. Gas is not a currency. You can't buy it, you can't hold it, you can't trade it. Think of it as just an abstract unit of measurement. It's a way to count how much work any given action takes, whether it's a simple transaction or a really complex smart contract. This is the best analogy, honestly. Think about your power bill. The actual energy you use is measured in kilowatt hours. That's a fixed unit of work. Now, the price you pay in dollars for each of those kilowatt hours can change, but the kilowatt hour itself is always the same. Gas is the kilowatt hour for Ethereum. And every single tiny little operation the Ethereum network can do has a fixed gas cost. Look at this table. As simple addition, that'll cost you 3 gas. But writing a new piece of data to the blockchain's permanent storage, whoa, that's 20,000 gas. Why? Because it's a way, way more intense operation for the network to perform. This is that meter in action. Okay, so if every action has a fixed cost in gas, how does that become the fee you actually pay in Ether? Well, this is where things get really interesting, because Ethereum essentially creates a real-time market to price all of this work. First up is something called the gas limit. The fuel tank analogy is perfect. When you send a transaction, you set a cap on the total amount of gas you're willing for it to use. This is a critical safety feature. It means that even if a smart contract has a terrible bug, it can't just run forever and drain your entire wallet. Nope. It'll just run out of gas and stop. And just like that, you've solved the halting problem. The other piece of the puzzle is the gas price. So if the gas limit is the size of your fuel tank, the gas price is what you're willing to pay per gallon of fuel. This is the part that changes. It goes up and down based on how busy the network is. If a ton of people want to make transactions at the same time, you'll need to offer a higher gas price to get a validator to pick up your transaction first. So in the early days of Ethereum, the math for your total fee was beautifully simple. It was just the amount of gas your transaction actually ended up using, multiplied by the gas price you were willing to pay. Simple as that. Offer a higher price, get in the front of the line. And why is there a line at all? Because the amount of space in each Ethereum block is limited. You can only fit so many computations into one block. It's like having a limited number of seats on an airplane. When demand for those seats goes up, people start bidding against each other, and that's what drives the price up. But this simple bidding system had its problems. It was chaotic. Fees could swing wildly, and people often ended up overpaying just to be safe. It wasn't a great experience. And that led to one of the biggest upgrades in Ethereum's history, EIP 1559, which totally redesigned the fee market. Here's a quick before and after. We went from that crazy first price auction where you were basically guessing what to bid to a much more predictable system with 2 parts, a base fee and a priority fee. The whole goal was to make fees less volatile and just make the whole thing less stressful for users. And for the most part, it worked. So here's how it works today. First, there's a base fee. The network itself calculates this fee automatically based on how congested it is. It gives everyone a clear, transparent price for getting into the next block. And here's the cool part. That fee gets burned. It's just removed from existence. Then, on top of that, you can add an optional priority fee, which is basically a tip that goes straight to the validator to encourage them to process your transaction even faster. And this is what that looks like for you, the user. In an advanced wallet view, you can see these sliders. You're setting the maximum fee you're willing to pay and a specific tip, the priority fee, to cut in line. This isn't some abstract theory. This is the system in action, right in your wallet. Okay, let's pull the camera back now and look at the really big picture. Why go through all this trouble? Why is this so complex? Because this entire gas mechanism, all of it, is what guarantees the health, the security, and the stability of the entire Ethereum network. So to wrap up what it does, gas secures the network by making spam attacks incredibly expensive to pull off. It allocates that limited block space fairly to whoever values it the most at any given moment. It gives developers a huge financial reason to write clean, efficient code, because sloppy code costs more. And bringing us full circle, it solves that original halting problem by putting a hard cap on every single computation. And because this whole market is transparent, it allows for amazing tools like this, a gas estimator. It can look at the network in real time and tell you, hey, if you set your priority fee to this, you have a 99% chance of getting into the next block. It turns a wild guess into a data-driven decision. To really hammer this home, let's just compare it to Bitcoin for a second. Bitcoin's fee model mostly cares about the size of your transaction, how many bytes of data it is. And that's perfect for a system designed for simple transfers. But Ethereum's model is totally different because it has to price computation itself. It has to price the work needed to be a true world computer. So if you take away just one thing from all of this, let it be this. Gas isn't just a fee you have to pay. It's the core engineering solution that takes the massive, crazy idea of a decentralized world computer and actually makes it work. It makes it stable, secure, and possible. Which brings us to a final thought. If gas is the incredible engine that powers this entire system, what kind of vehicles are people actually building to run on it? Well, that is a perfect setup for our next explainer, where we will dive deep into the world of tokens. Thanks for watching.